The S2.2 assignment or assessment is absolute value inequalities. It is going to be 50 points, and basically you are going to have questions like the study guide that you just completed where it's absolute value. Inequalities. This is going to be most of them. You are going to have 10 questions that are out. These are going to be 4 points each. So this part is going to be 40 points. And then you are going to have 5 questions that are regular or compound inequalities. And those are going to be worth 2 points each, bringing the difference of 10 points. So that's where we get the 50 points altogether. So 40 points are going to be for absolute value inequalities, and 10 points are for compound inequalities, and that's where we get the total amount of 50 points on this summative. If we were to remember the steps to solving absolute value inequality, flow chart that shows us and reminds us how to solve absolute value inequalities. So the first thing that you need to do is isolate the absolute value. Once you isolate the absolute value, you ask yourself if it's less than a negative. Now remember, this is absolute value. This is not regular inequalities. Regular inequalities you just solve like normal, remembering that if you multiply or divide by a negative, you flip the symbol. That's part of all of this. So in the process of solving for absolute value inequalities, after you isolate the absolute value, you must ask yourself, kind of like you did with the equation, is it a negative? Because if it's less than a negative, it's no solution, and you would graph it with an empty set 0 slash on the graph. And if it's infinite solutions or all real numbers, it would be when it's greater than a negative. If the isolated is not negative, then you go into asking yourself, is it an and? Is it an or? And remember that the word greater, think of greater, and less than, think of less than. So greater than inequalities are ors, less than inequalities are ands. Once you figure out if it's an and or an or, you go straight to set up your two cases. The given and flip the symbol, flip the sign. So if it was less than a number, it would then be greater than the negative. If the original was greater than a number, it would then be less than a negative. So with that little flow chart, you would go ahead and solve. So let's look at the equation or the inequalities that were on your study guide. Number 1 said the absolute value of 3x minus 4 is greater than negative 2. Well, step 1, isolate it. It's already by itself. Is it less than a negative or greater than a negative? Oh, it's greater than a negative. That means it's all reals or infinite solutions, whatever you want to write with that. All reals. And if I was to graph this, you would literally graph by shading in the whole line.
Wait, I thought it's...
If you forget that greater than a negative is all reals, think logically. This part here, the absolute value of everything, is always positive. So this is saying a positive number is greater than a negative. Yeah, obviously, always. That's why we write all reals. So that's another way of thinking of it. Number 2 on the study guide was solve and graph. The absolute value of 4x plus 8 is greater than or equal to 16. So, looking back at our flow chart, is it isolated? Yes, it is. I have the absolute value by itself. Is it anything to do with a negative? No, because 16 is positive, so you go to the next. Is it an and? Is it an or? This is a greater than symbol, so I already know that this is immediately an or inequality. Then, now that I've figured out it's an or, you go to the next step. Set up the two cases. The two cases are the given, 4x plus 8 is greater than or equal to 16, or the other one is 4x plus 8 is less than or equal than negative 16. And now you solve each. When I solve the first case, I get 4x is greater than or equal 16 minus 8 is 8. Divide by 4. X is greater than or equal to 2. It's an or inequality, so I'm going to rewrite the word or. And then for the second one, you minus 8 on both sides. And you get 4x is less than or equal to negative 24. I'm going to divide by 4, not by negative 4, but by 4, so I don't have to flip symbols. And I get x is less than or equal to negative 6. Now, I have my inequality, which I have to graph. When I graph that, draw my number line. Negative 6 is on the left of 0. Greater than or equal to 2 means it's a closed circle shaded to the right. X is less than or equal to negative 6 is also a closed circle, but it shades to the left. And if I was to write it in set builder notation, which I'm not going to make you write it in set builder notation, but if you remember to do so, that would be great. It would be x such that x is greater than or equal to 2, or x is less than or equal to negative 6. Remember, you have to have that. Number 3. Notice that this is an absolute value once more. Remember, you're going to have a mix of absolute value and not absolute value, so you're going to need to know when to not set up two cases and when to set up two cases. Okay? In this case, it's absolute value, so I'm going to go straight to my little flowchart in my head of how to solve absolute values. First of all, isolate it. Yep, it's by itself. Second of all, is it less or greater than a negative? Nope. Cool. Go to the next one. Is it an and? Is it an or? Less than, it's an and. Now, go to the next step. Set up your two cases. The given, which is 2x minus 8 is less than or equal to 2, and the opposite symbol, opposite sign, 2x minus 8 greater than or equal to negative 2. We solve each, add 8. We get 2x is less than or equal to 10. Divide by 2. X is less than or equal to 5. And add 8, add 8. 2x is greater than or equal. Negative 2 plus 8 is 6. Divide by 2. X is greater than or equal to 3. Remember, this is an and. That means that you have to graph it and put it in one inequality. When I go to graph it, 3 and 5, less than or equal to 5, closed circle shaded to the left, greater than or equal to 3, closed circle shaded to the right. So I'm an in-between, that makes sense. And when you write it, you have to remember to write the x in between, because that's how you write ands. X is between 3 and 5, so you use your less than symbols with the or equal, because that's what it says. And this would be the solution. So it's
Don't you write the whole? Can you like give us two extra like space?
number 4, 8 minus 2x within the absolute value is greater than or equal to 14. All right, so looking again, isolate it. It's already by itself. Is it greater than or less than a negative? No. Go straight to, is it an and or an or? Greater. That means this is an or. And then set up your two cases. Case 1 and case 2. Remember that it is flip symbol, flip sign. 8 minus 2x, flip the symbol, so now it's less than or equal, and flip the sign, negative 14. And then you solve each independently. Be careful with this one, though, because at the end you're going to have to flip symbols. When you subtract 8, you get negative 2x is greater than or equal to 6. I am then going to divide by a negative, which means I have to flip my symbol because that's the rule with inequalities. X is less than or equal to 6 divided by negative 2 is negative 3. This is an or. Now I'm going to solve the other one. Subtract 8 on both sides. You get negative 2x is less than or equal to negative 22. I am going to once more divide by a negative, which means I have to flip the symbol. And you get x is greater than or equal to positive 11.
Wait, are we gonna write it down separate?
Now with this, I go to graph it. Negative 3 is to the left of 0, 11 is to the right. Less than or equal to negative 3 is a closed circle shaded to the left. Greater than or equal is a closed circle shaded to the right. And it didn't change from my statement, so that is my final answer. So now I'm going to give you a couple of questions. Some of them are going to be absolute value, some of them are not. Your job is to know who's who, which is pretty easy because if it's got absolute value symbols, it's absolute value. And then solve it properly. With, and this is really important that you remember, when you're doing these questions, you have to ask yourself, is it an absolute value inequality or not? So, with the number 1, you notice there's no absolute value symbols, right? So you don't have to worry about setting up two cases. You just solve like normal. So I would rewrite, and then I would distribute that 2. So I would get 2y minus 36. I don't have to worry about setting up two different cases because there's no absolute value. Make sure you can recognize when you have to set up two cases and when you don't. You only set up two cases with absolute value, right? Now I just solve like normal. You can combine these because they're on the same side. What is 19 minus 36? Negative 17. So you get 2y minus 17. Rewrite everything else. I'm going to add 17. I get 32 is greater than or equal to 2y. Divide by 2. 16 is greater than or equal to y, which is the same thing as y is less than or equal to 16. If you don't remember to rewrite it with the letter first, your symbol is going to tell you the wrong way to shade. Now this graph is going to be, if this is 0 and this is 16, the graph is going to be a closed circle on 16, shaded to the left. And again, I know it's shaded to the left because when I have y first, this arrow tells me the direction of the shading. So if 16 is greater than y, y is less than or equal to 16. And that's my answer. Number 2. Number 2 is a compound inequality. And because it's in between 2, it is an and. I take this and I simply just solve all at once, minus 3 on all, because the x is by itself in the middle. There's no other x's on the left or right. I would get negative 5 is less than or equal to x, which is less than or equal to 6. -5 is to the left of 0, and 6 is to the right. And literally, this is an in-between, and it's an or equal to, so you have a shaded in between both. And that's your answer. For number 3, you notice that this is an absolute value inequality, which means you have to go through your entire whole steps of figuring out, first of all, is it isolated? No. Then move to the and or, then set up the two cases. As I heard some of you say, this guy is not isolated because you have that -3. So the first thing that you're going to do is what? Add 3 to both sides. And this is just, right now, all I'm doing is isolating the absolute value. That's the only thing I'm doing right now is that first step. Oops, sorry about that. So we get the absolute value of 7x plus 2 is greater than or equal to 25. Now from there, I can ask myself, is it greater, less than, a negative? And it's no, so I don't have to worry about these. I go to the and or. Is that an and or an or? Or, because it's greater. So when I go to solve it, I know it's an or. And what are my two cases?
7x plus 2 is greater than or equal to 25, and 7x plus 2 is less than.
Good. 7x plus 2 is less than, remember, flip the symbol, less than or equal to -25. Okay? Now, with this, I can solve it independently. I'm going to -2 on both sides. Yeah, you're going to get a fraction for this one. 7x is greater than or equal to 23. Divide by 7. X is greater than or equal to 3 and 21, 2 sevenths. Or the decimal part if you divided. Yeah, you could leave it as 3 and 2 sevenths. Then when you -2, don't forget, this is already out of the absolute value, so you don't have to worry that it's negative. You have to solve it. And you get 7x is less than or equal to -27. Divide by 7, and you get x is less than or equal to -3 and 6 sevenths. You're not going to have anything as crazy as those, by the way. It's an or, and so we have to graph it. Now, this is how you would graph it. If this is 0, 1, 2, 3, 4. If this is 3, 3 and 2 sevenths is somewhere to the right between 3 and 4. So it's a closed circle shaded to the right. And then the negative is -1, -2, -3, -4. It's going to be -3 and 6 sevenths, which is going to be here, closed circle because it's or equal to, shaded to the left.
Wait, are we going to have, wait.
Okay, so that was number 3. Number 4, is this an absolute value inequality? No. So this part, we don't have to worry about. It's just a regular inequality. The first thing you have to do is get rid of that division. So you multiply both sides by 3. When you multiply both sides by 3, what you're really doing is undoing that division. So you get, on the left-hand side, 4 plus x is greater than -12. Now we just solve like normal. -4, -4. X is greater than -16. Notice that, first of all, this is not an absolute value inequality, and second of all, it's not even a compound inequality, it's a single inequality. So this one, if this is 0 and this is -16, open circle, shaded to the right. Great. That was number 4. Number 5. What kind of an inequality is number 5? It's absolute value, so you have to remember all of your steps. So when I look at this, I isolate my absolute value, which is step 1, and it already is isolated because the absolute value is by itself. Is it less than or greater than a negative? No. Is it an and or an or? And, less than, so this is an and now you set up your two cases. Case 1 is the inside just as it is, and case 2 is the inside greater than a negative 14. Now you solve each. Subtract 8 to the first inequality on both sides. We get 2x is less than 6. We remember to keep going. A lot of you guys actually forget to divide by 2 on both sides. So we get x is less than 3. And now we're going to go to the right guy. Minus 8 minus 8. 2x greater than, what's negative 14 minus 8? Negative 22. I am now going to divide by 2 on both sides, and I get x is greater than negative 11. Now I graph it. Negative 11 is to the left of 0, and 3 is to the right. X is less than 3, open circle, shaded to the left. X is greater than negative 11, open circle, shaded to the right, and you notice that it's an in-between. Remember that because it's an and, you have to put the x between the two numbers, and you go least to greatest. Because that's basically what it tells you that you're doing. You're in between negative 11 and 3. Number 6 is also an absolute value inequality, so make sure that you remember your steps. Isolate it, it's already done. Is it an and or an or?
Yeah.
Less than,
Yeah.
and then two cases. Case 1, less than equal to 9, and case 2, greater than or equal to negative 9. Solve each, add 6, add 6. 5x is less than or equal to 15. Divide by 5, we get x is less than 3. And add 6, add 6. We get 5x is greater than or equal to negative 3. Divide by 5, x is greater than or equal to negative 3/5. When we go to graph this, negative 3/5 is between 0 and negative 1, and 3 is to the right of 0. X is less than 3 means it's open circle, goes to the left. X is greater than or equal, I'm sorry, it was less than or equal to, by the way. Remember, it was here equal to, so I made a mistake by not saying it was or equal to. And then this one was also shaded in, shaded to the right, so it's in between. And to write x between those two numbers, literally it's negative 3/5 x and 3. So negative 3/5 less than or equal to x, which is less than or equal to 3. That's the whole question.